This is very cool. This is 5-4. It's about multiplying and dividing rates. Here's what it says though. When rates are multiplied or divided, the unit of the answer follows rules of arithmetic on the units of the original rates. I'm going to read this to you because I think this is important. Rates can be multiplied or divided by other quantities. The units are multiplied as if they were numeric fractions. This is important. As if they were numeric fractions. Keeping the units in the calculations can help you understand the meaning. I think you've heard me talk about this. The units are really important. They help you set up equations. It gives you the information you need to decide whether something in fact is going to work out and be right. If your units work out, your answer is going to be right. If your units don't work out, your answer is going to be wrong. Now, forcing the units doesn't make it right. It just means you put it where they don't belong. So they have to remain associated with the right number. Now, there's a discipline in this that's called dimension analysis, and it means just what it says. You're using the dimensions in a problem to help analyze the results. So there's some nice work in here. This is a case of keeping the units in the problem so you can pay attention to them, recognize that everything worked out right, so in the end you got the units for the answer that you wanted. Example 1 is a great example of this, in converting from beats per minute to beats per year, and it shows you the conversion equation set up with everything in the right spot so that we have minute over minutes. Plural of minutes is the same as the singular, so minute and minutes are considered the same unit, hour and hours the same, day and days the same. But we were able to do this conversion and end up with a solution to the problem. Rates are often used in formulas, and it's helpful when we have a rate to be able to get it into the right form for the formula. So we've got a guided example number 2. It says explain why a train traveling 68 miles per hour is traveling about 100 feet per second. So the goal is to convert miles into what? We're going miles into feet. And we're going to convert from hours into seconds. That's our goal. So we use the conversion rate so the units cancel in the numerator and denominator just like fractions. 68 miles per hour equals 68 miles per hour times 1 hour times, so 1 hour per what? What are we trying to get to? We're trying to get from hours to seconds. I mean, I got seconds here, so that's going to be minutes. $60 minutes. So 1 hour is 60 minutes, and 1 minute is 60 seconds. So 1 minute is 60 seconds times, what do we know about miles in its unit? We need to know how many feet are in a mile, and that's something I think a lot of you do know, and if not, it's one of those little factoids it's probably good to get into your head. There are 5,280 feet in 1 mile. So now we've got our conversions. We've got our feet per mile. We have minutes per second, or minutes, 1 minutes per second, 1 minute per 60 seconds. And then here we have 1 hour per 60 minutes. We're going to put all this together, and it'll be 68 times 1 times 5,280, and 1 times 5,280 is 5,280. So right here we get 5,280 feet, and down here underneath that, that's going to be in seconds, because in this I got 1 hour is 60 minutes, so 60 minutes times 60 seconds, but we canceled out minutes by, we had minute up here and minutes here, so the minutes canceled, so I'm left with seconds here in this last little bit. That's seconds, which leads me to my answer, which is an approximate answer, and that's going to be about 100 feet per second. So about 100 feet per second. So 68 miles per hour is about 100 feet per second. Now normally I would use a little squiggly equal sign here to indicate an approximate, not the actual equality, because that's not what we meant. So that's it. I'll go through another one like this, so if this was a little confusing to you, perhaps the next time we look at it will be a little bit more helpful. This last part is about using reciprocal rates. We see in the guided example we used 1 hour per 60 minute, and in the previous example, example 1, we used 60 minutes per hour. Well, those are reciprocal rates. If we multiply those together, we'd end up with 1, and the units would all cancel out. It would just be 1. So using reciprocal rates allows us to get to a 1. Now, one of the things you might be asking yourself with this is, aren't we violating our rules of algebra by not multiplying both sides of the equation by the same thing? Well, here's the nuance to this, is that 60 minutes equals 1 hour. They mean the same thing. 24 hours is 1 day. 365 days is 1 year for most years. So this is a form of a 1. These are equivalent amounts, but numerically we express them differently, and it changes the numeric reading of it. So 70 beats per minute is equal to 36,792,000 beats per year. These mean the same thing. They're expressed with slightly different units. These are forms of a 1. It's a convenient form of a 1 where they're equivalent values over each other, so that is a 1. So it's like we're multiplying by 1, but doing it in a way that allows us to shift the meaning of the problem. So reciprocal rates are just that: students per class, class per students. Read through it. We'll be working through it. Make sure you get your units in the right place. They stay with the numbers. So in this example down here near the bottom of the page, I have 23 students per class. The 23 stays with the students. The 1 stays with the class, because that's 23 over 1. So keep them together as you're going through it. You'll do fine. Make sure your units work out. Everything cancels. Got a few more examples for you. Okay, we're taking a look at some extra examples for 5-4. First, I want to kind of move from some of the hand waving about why the conversion rates work to look at a few things. Let's look at some that we know. We know that 12 inches equals 1 foot. Let's pick something else we know. I don't know, 5,280 feet equals 1 mile. 2.54 centimeters equals 1 inch. These are conversion factors. We know that they're equal to each other. And so if they're equal, then if I have 1 foot divided by 12 inches, effectively I'm saying I'm taking, both of these are 1 foot. They mean the same thing in terms of dimension. They're just expressed using different units. So 1 foot divided by 12 inches is effectively just 1. There's no units to it. Well, excuse me, there are units to it. They're feet per inch. But this is effectively just a 1 because it's the same thing. 5,280 feet in 1 mile. Same thing. So we're taking something that is represented in different ways but equals the same physical distance or quantity, but with different units. And we can take that to be a 1, which allows us to do our conversions. Let's take a look at a few and see how it's going to work. We'll start down here with this first example. On average, Cairo gets 2 millimeters of rainfall per month. How much rainfall does Cairo get in 1 year? Well, what we're looking for is what's the answer? So the equals part of this is how much rainfall does Cairo get in 1 year? And that would be rain per year, right? Rainfall per year. So that's the rain in Cairo per year, and it gets 2 millimeters of rainfall per month. So I'm guessing I probably want millimeters per year, right? So rainfall per year. Let's change this now that I'm reading that more carefully. So it's our rainfall, but it's the rainfall in millimeters, and millimeters is just that, millimeters. And so we get 2 millimeters per 1 month. I want millimeters per year, so millimeters needs to be in the numerator. The date, I mean the time interval, month or years, has to be in the denominator, so I need to convert from months to years. So I'm going to convert how many months are in 1 year. There are 12 months per 1 year, and I'm going to have millimeters per year. So months will cancel out. Month over month is just a 1. 1 times 1 is 1. 2 times 12 is 24. So we have 24 millimeters of rainfall, approximately, in Cairo in any 1 year. That's our first one. Here's our conversion factor we use, 12 months per 1 year. Next up, this one asks us to explain why a car traveling 120 kilometers per hour is traveling about 75 miles per hour. Use this conversion factor that 1 mile is approximately 1.6 kilometers. So the goal is to convert kilometers to what? That's our first question here. So we want to convert from kilometers to miles. We've got hours in there, so we want miles. And so what we want to know is 120 kilometers per hour. We want to know how many miles per hour that is. So we want to convert kilometers to miles. 120 kilometers per hour times, and they gave us a conversion factor. I want to have miles in the numerator. So 1 mile equal to 1.6 kilometers. 1.6 kilometers. And I've got miles per hour. Kilometers will cancel out. So 120 times 1 divided by 1.6 will give me my answer. So 1. And that equals 75 miles per hour. So we've been able to show by going through this calculation and setting up our conversion equation that indeed 120 kilometers per hour is equivalent to traveling 75 miles per hour. Well, that's it for examples for 5.4. You've got covering the reading and applying the math. Work through it. Include the units in your problems. I think you're going to find that this really helps in getting these problems set up, and it's a really very powerful tool for solving equations and making sure you get it right. Good luck on the mastery quiz, and I'll see you in class.